In this tutorial, I'll explain how to prepare the model of Oldham coupling using SolidWorks. So this is the Oldham coupling. Here my aim is to prepare the sectional front view and side view of the Oldham coupling. Here in SolidWorks, three modules are there. First one is part modeling, second one is assembly, third one is drawing. First I will make the models of individual parts like flange, central disc, shaft, key. After that I will prepare the assembly, then drawing. First click on part model and OK. This is the SolidWorks environment. This is called as a command manager. This area is called as feature manager. This is called as heads up view toolbar. So first, to start with any drawing, you have to select the work plane. Default work planes are front plane, top plane, right plane. I want sectional front view and side view. So this particular circular cross section I require in the side view. So that's why go to the right plane. So that is representing the side view here. Then click here. Go to a new sketch. Select on the new sketch. Then in the sketcher tab, go to circle command and draw a circle like this. Then the circle diameter is, go to dimensions and click on the circle, then automatically it will ask for the dimension. This circle dimension is, 3.5D. So here 3.5 star D assume as some 30 mm, that is the die of the shaft. So that is 105. Then exit from the sketcher. See this in the isometric view. So this particular button will give different views. Go to isometric view. Then go to the features tab. Now take the extrude feature. Extrude this to a distance of 0.9D. So this is 0.60. This is 0.3D plus 0.3D plus this is 0.3D. Total 0.9D. Extrude this to a distance of 0.9 start 30. Okay. Click on OK. So total extruded distance is now 27 mm. Then I want this hub portion and I want this hub portion. This hub diameter is 2D. Then for that purpose, click on the center button to rotate this in the three-dimensional plane, something like this. Then select this particular flat surface. Then go to the new sketch. Now this particular sketch plane you can see from the left hand side. Go to the left hand view. Go to sketcher. Take the circle command. Now take the circle dimension as 2D. Okay, exit from the sketcher. Now extrude this. Go to again features tab. Extrude this to a distance of D, that means 30. Here you can see this distance is D. Okay. Now I want to get this slot portion. Here you can see that slot clearly. So this particular depth is okay, here it is 0.60. So previously I have taken this as 0.9D, but actually it's 0.60. So I want to do that correction. For that again go to this particular feature. Click on this edit feature. So here you select this as a 0.6 start 30. Okay. Something like this you can do the corrections. So now this is 0.60. Now this particular slot is, this width is 0.5D, depth is 0.3D. Okay. Now for that you select this particular flat surface, go to the sketcher, Then see this from the right hand side. Then go to sketch, select the center rectangle, take this as center, draw a rectangle like this, go to dimensions. This depth is 0.5 star 30. Exit from the sketcher. See this from the isometric view. Now go to features tab, take the extruded cut feature, and this extruded cut distance is 0.3 times of D, that means 0.3 star 30. Click on OK. Now this particular portion is ready. This portion is ready now. Now we have to make the shaft hole with keyway. So for that purpose, take this plane, go to the sketcher, see this from the left hand side, then go to sketch, take a circle command, then this diameter is 30, dia is 30. Now keyway, for keyway you draw one circle here, one rectangle here. For keyway, draw the rectangle. For keyway, take the rectangle command and draw one rectangle here. So keyway dimensions are, assume that it is the square key. Then this is d by 4, that means 30 by 4. This distance is again d by 4, it is 30 by 4. Now zoom this area and go to the trim command and remove the unwanted portion like this. Keep this in the power trim option. Okay. Exit from the sketcher. See this in the isometric view. Go to features. Again take the extruded cut feature. Now here, instead of blind, you go to up to surface option and select this surface. Then up to this surface, the material will be removed. Now we got the flange like this. So our first part is ready. Now save this part 1, flange. Okay, save. Now again take one more part. So here my aim is to make this central disc. For the central disc also, diameter is 3.5D. This central portion diameter is 3.5D. Again take the right plane, go to sketcher, take circle command, take this as 3.5 star 30. Now exit from the sketcher, go to the isometric view, go to features, extrude this up to 0.9 star 30. Now, so here this width is 0.5D, this depth is 0.3D. So now to get the projections, this projection and this projection, remove the material here to get these projections. So I am taking this particular plane, create a new sketch on this plane, see this from the right hand side. Here I am taking one reference line like this, then go to the rectangle command, take the corner rectangle, draw one rectangle like this, then go to dimensions. From this line to this rectangle, this particular distance is 0.25 star 30. Total distance is 0.5D, that's why I am taking half of that. Okay. Now go to the mirror command, take this portion as the entities to mirror about, select this line. Here at mirror about means select this. These are the entities to mirror. Okay. Then exit from the sketcher. See this in the isometric view. Go to features, go to Extruded Cut feature. Here you take 0.3*30. Okay. Now we got this projection. Then go to this side. Again take a new sketch. See this from left side. Again repeat the same procedure. Take the center line. Here draw the center line. Then go to rectangle command. Draw one rectangle like this. Then dimensions. Here to here, this dimension is 7.5. Then go to mirror command. Select all these entities. About this line I want to get mirror of these entities. Okay. Then exit from the sketcher. See this in the isometric view. Go to features. Go to Extruded Cut feature. Again this distance is 0.3*30. It means 9 mm. Okay. Now the central disk is ready. Now save this. This is part 2. Central disk. Now here I am going to draw the shaft. Take a new sketch in the again right plane. Take the shaft diameter as some 30 mm. Exit from the sketcher. Shaft length I will take as some, here D. This is 0.6D. This 1.6D. Around 2D. 2D I will take. This is 2D. That means 60 I will take. Okay. Then I will make the keyway. Here take a new sketch. See this from the left side view. Then go to sketcher. Go to the center rectangle. Here at this quadrant, take the key dimensions as D/4, 30/4. And here also it is 30/4. Now go to features tab, take Extruded Cut option and take this length as 1.6, 1.8 or 1.75*30. Okay. So shaft with keyway is ready. Save this. This is third part, shaft. Next take one more new part. Here my aim is to make the key. Again see this from the right hand plane. Now takes again center rectangle. Dimensions are D/4 and D/4. Okay, exit from the sketcher. See this in the isometric view. Go to features tab, take extruded feature. Then extrude this to 1.65*30. Okay. Save this as key. This is part 4. Key. Now I will make the assembly. So instead of making the assembly in a one step, first I will make one sub assembly. In this sub assembly I am consider the flange, key and shaft. Then these sub assemblies I will join with the central disk. Observe here. Browse. First I will insert the flange. Next take the shaft. After that insert key. These three parts I will make as one sub assembly. Go to mates. Here select this particular cylindrical surface and this cylindrical surface. Okay, these two are in concentric mate, but here I want to change the alignment like this. So click mate alignment button here, anti-align option, then it will be something like this. Now I can move it like this. This is moving inside the shaft, is moving inside the shaft hole. Okay, now I want to insert the key. Then select this top surface, and here this top surface, and select them coincident. Then take this particular side surface and this side surface of the shaft, then keep them in the coincident mate. Then again take this side surface, don't take the edge, take this surface and this surface, keep them again in the coincident. After that, this key must be at some distance from this edge. So that's why go to distance mate and select the distance as some 3 mm. Okay. This surface and this surface must be at some distance. So the distance is some 20 mm. Okay. Now flange with the shaft and keyway is ready. Okay. Now save this as some sub-assembly. Now save. Name this as a sub_Oldham Coupling. OH. Go to assembly. Now insert the sub-assembly. Next again insert the sub-assembly, because we require the sub-assembly 2 times. Then insert the central disc. Now go to mates. This surface must be in contact with this surface. Okay. Then this top surface must be in contact with this bottom surface. Okay. Okay, now we can keep these two like this. Then this surface must be in contact with this surface, but alignment must be in this way. Okay. This surface must be in contact with this surface. Okay. Then see this in the isometric view. Okay. Now we have to keep the axis of these two shafts at some distance. That's why I want to do some modification in the part such that I can see the axis and I can maintain the distance between the axes. For that, go to part, that is flange. Open the flange. Then here I will make some modification. I will take a new work plane, that is front plane I will take. In the front plane I will draw one sketch. In this sketch I will draw only the axis. Here I will draw only the axis like this. Okay. Exit from the sketcher. See this in the isometric view. Here I am seeing only the axis. Close it and save it. Automatically the change is reflected in the assembly. Here in the assembly now you are finding the axis. Now see this from the front view. Slide it like this. Here I want to maintain some distance between these two axes. Go to mate, select this axis and this axis, and go to distance mate. And what is the distance? You observe the distance is 0.4d. Then here you enter the distance 0.4, start 30. So that is 12 mm. Automatically you can see that distance here. Now when you are seeing from the right, it will be like this. Seeing from top, it will be like this. This is the isometric view. Now the total assembly is ready. Click on OK. Then save this. Now save all as final assembly. select drawing. Here go to the custom sheet size, and I want to print this on A4 size. A4 size dimension is 290 by 210. Okay, then browse this and insert the final assembly here. This is the front view, this is the side view, this is the isometric view. So isometric view I want to keep somewhere here, but I don't want this front view. Okay, delete this. I want sectional front view. Go to view layout, go to sectional view, select the section like this. Okay, this is the sectional front view, this is section AA. So I want to increase the size, so go here, instead of 1:2 go to user defined, go to user defined scale, take 1:1.5. this also you just change as go to scale, user defined 1:1.5. okay. Now here we have to remove the hatching for fasteners, that means this. So here we are getting small overlapment of this particular projection with shaft, that's why we have to do some modification in the assembly. Go to the assembly, go to sub assembly. So here this distance we have to change, this particular distance we have to change. This distance is 20, so make it as some 25. okay, close it and save it. That will be reflected here. Now it is good. Now select this, go to properties, then go to section scope, select this shaft, this key, this shaft, then automatically hatching is removed to these shafts and keys. Those are the fasteners. For shafts and fasteners we have to remove the hatching. Okay, then go to annotate, go to the center line, select this shaft, automatically will get the center line. Select this shaft, will get the center line, extend this like this. Then go to center mark, click here, we will get one center mark. Click on this circle, we will get another center mark. Okay, then go to smart dimensions, start applying the dimensions. This is dia 30, then this hub diameter is 60, then this particular dimension is some 18, this is some 9, this dimension is 15. Okay, something like this we can apply all the dimensions. Suppose this isometric view size, if we want to decrease, we can decrease, or we can shift this particular view to somewhere here. Okay, then go to annotate notes, here write the title. This is the sectional front and side view of Oldham coupling.